Hello everyone. We will starting this keynote session within 5 minutes. Hmm. 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 Mhm. Started. Yeah. Hello everyone. Good afternoon. I am Supriya More, Assistant Professor at SSMS IoT from IT Department. I welcome you all to this fifth IEEE International Conference on Emerging Smart Computing and Informatics, ESCI 2023. Before the keynote session start, here I will give you in brief introduction to our college. All India Sri Shivaji Memorial Society funded by late Chhatrapati Sri Shahu Maharaj and H.H. Sri Madhavrao in 1917. The society is dedicated to the noble cause of military, general, technical and management education in India. 20 institutions are under the ambit of society. The society management is very pragmatic and progressive. The All India Sri Shivaji Memorial Society Institute of Information Technology was established in 1999. It is a self-financing institution and it is affiliated to the Savitribai Phule Pune University. It is approved by the AICT, New Delhi, and the Director of Technical Education, Government of Maharashtra. The institution is accredited by NAC with A plus grade, and 5 UG program have been accredited by the National Board of Accreditations (NBA). So today our keynote speaker is Dr. Bruno. Dr. Bruno is the co-founder and the tech lead at the Core Data Motion. He led the entire technology transfer process of the company from the early detection of an upset in the market to the concept and evaluation of the idea, the creation of the prototype and the current product. In his career prior to founding Core Data Motion, he was an entrepreneur of a successful audio-visual production company, software developer, web developer, interaction designer, 3D artist, and STEAM technology educator. One of the passion that guide his professional career is the investigation of the border between art and technology. With the aim of creating unique experiences, mixing the traditional art, animation, programming, virtual reality, and personalized user interfaces. At the same time, his curiosity about the world of technology and mathematics led him to enter the world of programming, studying the C++ and Python. So today's title is of this keynote session, developing an open source motion capture framework in the 2020s. Okay, welcome sir.
Hi, everyone. And, can you hear me correctly?
Yes, sir.
Okay. So I will start. I will start by sharing my screen with the presentation. And please tell me if everything is okay, because at some point I won't be seeing you. So I will share my screen. Okay, you're seeing my screen?
Yes, sir. It's visible.
Okay, I will not put it full screen. Please confirm that everything is correct in a few seconds. Oh, okay. We are good to go. Can you hear me and you're seeing my presentation?
Yes, sir.
Great.
Audible and visible both. Yeah.
Right, so I will begin.
Okay.
So thanks for the introduction. Yes, I'm Bruno Laurencich. I'm the tech lead of this startup called
Screenshot.
DataMotion. I came from Argentina. I'm currently in Europe, in Italy, and this is a startup based in Barcelona, in Spain. So yeah, just to point out, I might be, I speak English with this Spanish accent. So please, if I say everything, I will try to be as clear as possible. But probably when I start speaking, my normal way of speaking English will pop up. And please, if I'm not getting through correctly, or if something is not understood, please stop me and let me know. So that being said, I will start with the presentation right ahead. So yeah, as I told you, we are a startup based in Barcelona, and our main activity is the development and maintenance of an open source motion capture framework. And I think many of you won't be familiar with what motion capture is. So we'll be reviewing during this talk what it is all about, how it works, and what it is used for. But since this is a keynote, I wanted this presentation to be more inspirational for you than technical. And I guess that here this is a tech conference, and I might assume that we have people in the audience coming from really different backgrounds, and together that's why together with the technological aspect of these presentations, what I really want is to tell you the story of how this company how it started as a personal project developed by me for passion and because I wanted to do something with this technology at the beginning. And as I in the presentation already told you, I also make digital art. So in particular, I wanted uh, a motion capture framework to do some artistical work in scene with dancers and to re-elaborate that graphically and use light projections. And the time when I started this project was in 2015. There were no affordable commercial options. So I decided just to go ahead and start doing the system by my own. I didn't knew at the time that it would let me to develop a whole system that nowadays is used by many people in the world. But yeah, that's how it started. So I also assume that some people in the audience might have the idea to start a new project, or perhaps they have a side project that you will want to push forward, or you at least is something that an idea that crossed into your mind. So I want to share you some of the aspects that of my experience with this project that I think that will be interesting for you, together with the technical aspects. So, okay, so let's start with the beginning and some background. What is motion capture? Because I'm sure that many of you have heard of it, but they are not completely sure what we're talking about. So let's go to it. Motion capture is a technology that allows you to digitalize the human movements. Okay, and you will able to translate those movements and to a virtual skeleton. Okay, a virtual skeleton can be seen, can be visualized like something in the left, okay, in the picture of the left, a set of bones interconnected that reassemble the real skeleton. And I guess up until now, everything can agree that it's not something so hard to understand, but a question that often arises when we explain about this technology to people to non-experts, of course, is okay, but how this information can be used for, what it is useful. And well, there are plenty of application fields of motion capture across many disciplines, like, for example, clinical diagnosis, sport research, augmented reality, and virtual reality, and video games integration. But perhaps the easiest to understand for outsiders is 3D animation. We often use this example that I will show you in a second, because I assume that many of you have seen the film Lord of the Rings, where there is this character Smeagol or Gollum, which is a character. This is made on computer graphics and is then inserted into the scene. Okay, it's made with computer graphic techniques, 3D computer graphic techniques, render techniques that are known in the industry for years. But the thing with this character in particular, and nowadays with almost any character that is inserted into a film, is that the movements of the digital character were taken from a real actor. In this case, the actor was called Andy Senkins, and this actor performed in a special set. Let me show you a few seconds of this video. Okay, as you can see here, this is the real actor with a special suit, in a special set. And as you can see, creators took the movements of the actor. I just showing you a few seconds, but I guess you already are familiar with this technology, so why am we doing so much? And they applied those movements to this mesh, to this character that we see now. Okay? The character itself is realistic. Let's see. Again. This is a real actor, he's moving. And then those movements are applied to the character is raised, and the movements are applied to this character. Okay, this character is realistic, but in order to make the movement realistic, you want, for example, to grab them from a real actor. Okay, so this is one of the biggest uses of motion capture, and that's what we do. Let me pass the next slide. Here it is. So, okay, now I must make a parenthesis because there are several types of motion capture. There are several types of technology can be implemented to achieve motion capture. What the actor was using in the video we've seen before is a completely different of mock-up than the one that we developed, okay? He was wearing a black tight suit with bright reflective markers that you can see more clearly in the picture of the left. The actor is wearing that. Those markers are just balls of reflective material. They are not sensors, okay? In this type of capture, there are a set of specialized cameras that are disposed in known locations, and they're calibrated to have an accurate positioning of the location of each one of the cameras. And the cameras can see the position of those points in the body. And after a good amount of processing, they are able to get all together. A central processing unit is gathering information from all these cameras, and they are obtaining the 3D position of each one of the points in the space. And then after another amount of processing, they are able to understand how the human skeleton is positioned and is moving inside those moving points, okay? This type of technology is the one that is used in cinema and when you need great precision and when you have a great big budget, okay? Because this type of technology is the most precise and accurate technology of motion capture that you can obtain nowadays. But it's also the most expensive one, not only because the equipment is expensive, but also because you often need to maintain a whole set dedicated to keeping this equipment, okay? So this altogether makes this expensive technology. There is an alternative. There are many ways of implementing motion capture, but mostly if you go to the market nowadays, you will find these two types of technology. So the other type of technology is the one that we develop, is called inertial motion capture because it relies on inertial sensors, okay? Basically, the building block of this technology is what is called the IMU sensor, which is an array of sensors. IMU stands for inertial measurement unit. Okay, it's basically an accelerometer and a gyroscope, and also a magnetometer, which is not technically part of the IMU, but normally they go together. So yeah, it's not technically correct to call them all IMU, but yeah, we can do it for this presentation because it is easier to say. Okay, IMU. Yeah, this technology works completely different from the other one because what you have positioned in your body are the sensor itself. So the sensing units are in your body instead of just passive trackers. Excuse me. And they can feel the linear acceleration, the rotational velocity, and the magnetic field flow. We will see later how this works. But basically, the process consists on grabbing the orientation, the 3D orientation, instead of the location of each bone, and then apply that to a skeleton that will mimic the movements of the performer. Okay, this is a portable solution. You don't need a set, as you can see in the picture of the right. This is not our system, but I included because you can clearly see that everything can be contained in a suitcase, and in a PC you are able to capture everywhere. You can go in the middle of the woods and start capturing as long as you have battery. Yeah, you need a studio, which the equipment itself is much less expensive. So it is a solution that is being implemented a lot nowadays, that more and more people is starting to use motion capture, and also small producers or smaller teams are starting to use motion capture. A more affordable solution is something that they want. But yeah, the counterpart is that this type of capture will never be as precise as the optical one. But no, I don't know if they never, but it's currently no perspective for this type of motion capture to be as precise as the other one, but it is still precise enough for most applications. So yeah, it's a great alternative. And yeah, let me start with the story of this company on this project, and because this for me is it's a nice one to tell. So this is started several years ago. As I told you, I was trying to achieve a motion capture solution for my own project. So I started to investigate around and to build prototypes. And what you can see on the left is the very first prototype, which was able to capture just an arm, and it has this look of a hacky style of hand soldered components, like all put together with tape and whatever I had in hand to make this work. So that's how I work with this in the early days, just like assembling prototypes, making some development, making some tests. And as soon as this was then evolved forward, and as soon as I had something that was usable and was replicable, of course, not this. At some point, I had a prototype that was composed of several sensors, more similar to the one that we see on the right, which is the current state of the system, in which we have sensing nodes that can be interconnected. We have a central processing unit that can be replicable, and yeah, you are able to deploy this for a full body gear. So as soon as I had that, let me go to the next one. Oh no, this is not the next one. This is the next one. Yeah, I decided. I don't know why, because I'm really a supporter of open source projects, and I really like that way of doing software and sharing knowledge. So I decided to publish everything. Yeah, I created repositories for the code and the hardware, because yeah, from the beginning this was a hardware and software open project. Okay, so the sources, the schematics, and the bill of materials and instructions for building the hardware itself were published, because for this project you need this specific hardware to work with. And yeah, together with that, of course, I published the software. I picked licenses. I decided to go with restrictive licenses because they grant the code to remain in the public domain no matter what. So yeah, it's in order for me to prove my commitment to this code, this open source philosophy, I went with all these licenses, and as we will see, it was a great decision, at least what I think now, and how things are going out seem to prove that this was a good idea to do. There was also a project page in a site called Hackaday, in which I have a log with all the progress of the project, where people can went in and see what's happening. There was I created a wiki with all the information about how the project works and how can you build it and how can you use it and whatever, and all the information was there in a wiki, so it was also open to public editing. And the most important, or the biggest part of this project was a forum, okay, a place where people were interested in the project can go and discuss about it, and mostly at the beginning ask questions, ask support, because it's not an easy project to do in your home, but there was people coming in. It was amazing. It was magically people starting to appear here and to participate and to ask question and support, because they were trying to build it at home, and at the beginning we didn't have as much information, and we didn't have as much software layers that nowadays make the whole process much easier. So there were a lot of really brave people dedicating their time to this, and for me it was a great experience. And they gave feedback and they collaborate with the code. And yeah, during the early phases of the project, I received support from a lot of unknown people, and without them, this project would have almost certainly been stuck. Okay, so yeah, a healthy community like this, which was created, really helps pushing a project forward, especially at the beginning. Not only technically, but also gives you the will, you makes you want to keep on doing this, because you see that it's being used and people is receiving it positively. I guess also wanted to make a few points, because I remember at this time when I created the forum. Of course, it was not something I made randomly. I wanted to create a community to support the project. I knew at the time how important this was. I was surprised that it also came out well, but it was something that I wanted to. And I remember being in going to talks and conferences about community building and asking myself, how can you build a community? And I'm pretty sure that if any of you is starting a project or is with an ongoing project at the beginning, is something that a question that you're asking yourself. And what I can tell you is that if you give people something that is useful for them, and they see that you are committed to keep it useful, you are not trying to trick them into something strange. Of course, making something a project open source is a guarantee that you are giving them something and you will not take that away. And yeah, if all that happens and you give them a place to gather, they will start coming. You don't know where they came from, but they find out about the project. They also the word of mouth really helps here, because if they like the project and they see that it's useful for them, they will surely be talking to friends and colleagues, and they will also join in, and you create this snowball effect that is virtually the only way of building a community. So yeah, that's my advice if anyone is trying to do something like this. And I will like to take the opportunity to thank again, as we do every time that we have some time in public, to thank these amazing people that helped build this. And yeah, this project wouldn't be what it is without them. And yeah, let's go to the part where we talk about free software, because it's also an important part of this project. Okay, and free software is something that is normally taken from granted by most developers, but free software is directly or indirectly the foundation of almost all software that we use today. This is particularly true for software distributed under non-proprietary licenses like ours. And I guess that most of you are aware that you can find open source packages to perform virtually any task in IT, and often of excellent quality. Since we distribute under restrictive license, as I already told you, as mostly GPL, we can integrate with any open package out there. And this was, as I was telling you, a great decision at the beginning, because it gave a great push to, in the early days when there was just one developer that working on this on his spare time. So at that time, when I needed to create something that was workable, that was usable, being able to directly implement big chunks of features already created by talented people was crucial to obtain a working system in a small time that I had available. Of course, again, this is not something new, what I'm telling you. Probably all of you know about the importance of relying in external libraries to not reinvent the wheel. But what I want to transmit here is the power and freedom that you gain when you choose to publish under open licenses, okay? This is also that election that choose is also a controversial decision, because you will normally ask yourself, okay, I'm dedicated a lot of time and energy to this project. What will I gain? How do I take back my effort if I just give it away? And of course, this is also in a in a further step when you start to need to approach investors to make your project grow. This is also a question that the investors, the potential investor, will ask over and over again. Okay, you're open source, so you're asking me to put some money on it. How will this money come back? And let me just tell you that there are a lot of answers to this. I won't be digging much into this part, because I'm not the expert in this. I'm a technical expert who happened to be leading this type of project. But there are a lot of commercial models for open source, and there's a lot of information out there. And yeah, I encourage you, if anyone is interested, to go search for it, because there are answers to those questions that I made before, and you might be asking if you were planning, you're thinking on doing something like this. So yeah, and let me tell you that another good things in marketing terms about making a project open source is that it expands fast, because you are doing something that belongs to people by definition. People feel it as it was their own, because it actually is, and they tend to really commit to the project and really as I was telling before, like with the community, like tell to people, and everyone finds out really quickly the existence of this project, because they don't need to spend money. There are no barriers for people to start using it. Yeah, basically that. And yeah, it's really how is it? Excuse me, I lost my word in English. So yeah, basically that's the point. I would like to mention we use a lot of software packages, libraries, and our framework is in big part composed of external libraries. We rely heavily upon this type of external packages, but in particular, a software package that was really important from the beginning. And in particular, I came from a world of 3D animation, so I was a user, a big fan of this software, which is called Blender. I don't know if any of you know it. It's a 3D manipulation package, open source, also published under GPL licenses. It is a complete, really powerful software, which it was already powerful, but in the past years, it expanded further. And nowadays, it's an excellent alternative, a competitor of any other commercial 3D package. And it has the good quality for us that it has an interface that is completely scriptable in Python. So whatever you can do as a user, you can do it in Python and create scripts and create plugins or add-ons. And so in the early days, it was crucial for us to test what we were doing in a 3D environment, to visualize things, and yeah, it was to obtain feedback of what was happening in the software, okay, visually, because at the end, it is the output of what we are doing is the skeleton, and if you can see the skeleton, you can see most of what's happening. And nowadays, I will tell you later, one of our clients is an add-on for this software where you can capture directly in there and gives you a lot of flexibility. And yeah, it's nice to have. And again, for the people also behind Blender, because it's also a great community. Yeah, and another thing that happened on this history of an evolving project becoming a startup is that, well, at some point we gathered a talented team, and it was great because all the contribution that I was telling you about is great, but at some point when a project starts to get big, it's not enough. You need to have a core team maintaining the software and the project because the community itself cannot do it. And of course, one person by its own cannot do that. So what happened in this particular project is that at some point when the project was a solo project by me, Flavia and Juancho came in. This is the ones to my right in the screen, in the upper part. And they are not technical profiles. They are administrative profile and communicational profiles. Juancho is the CEO right now. Yeah, from the beginning. I would like to point out that we technical people tend to think that a technical project is just about that. It's just the technology. But I can tell you that it is not. At that point, they enter, we needed to push the project forward, and they were not technical, but they were exactly what the project was needed. People who take care of making this consolidate. No, okay, because of them, we consolidate this project as a startup, and only then we started gathering technical profiles that came into the team and joined the team are the people who are nowadays developing the project. Okay, so yeah, just wanted to point out this something that everyone says, and I'm enjoying the people that giving this type of advice for people who are starting projects, technical project. Like really, it's really important to collaborate with non-technical profiles, and they are with the engine that will push your project forward apart from the technical part. Okay. Next slide. Okay, here it is. So again, with this story, the project, now we have a startup consolidated, we have a system that is working, people is using that, we have collaborators, but this is a nice part of the story, and I would like to tell you a lot about this, but I will have to sum it up as much as possible. I will try to be able to explain this in a single slide, but the thing is, one tends to think that a project is self-contained and that you can do whatever you want with it, given that you have the technical and economical resources. But the truth is that when you start a project, or while a project is ongoing, this is inscribed in a historical, economical, and social environment. Okay, and the possibilities for it to grow and develop are highly influenced by its environment. In this particular case, what I'm talking about is the economical and productive situation that was taking place in the first, mostly in the second decade of the 2000s, in which we were experiencing a big, enormous availability of electronic products. In particular, I'm talking about electronic components, okay, chips and semiconductors and whatever. At that time, a few years ago, it's not so easy, but things happen to change really quickly. At that time, it was really easy to get and to use electronic components for a common user, a user that is interested in dealing with electronics. I don't know if you heard about the maker movement, this movement which was really active some years ago and really encouraged people to experiment with electronics and share their discoveries. And there was this big community. with a lot of hackers and makers. We were working with electronics mostly on their own place or in the local fab lab, and they were enthusiastically sharing their work with everybody. And this was the situation in which core data was conceived and core data started to take place. Okay, I myself was part of this movement and really enjoyed working in fab labs, sharing with people. I don't know if you know the concept of fab lab. Is this local place, a fabrication laboratory with electronic equipment, 3D printers, and everything that is needed to deal with this type of project. Yeah, there was this. There were online communities and local communities which were basically happening inside the fab labs, and it was really interesting because it was taking place in many cities all over the world. Each city has one or several fab labs, and they were interconnected with each other. So you were able to um, use the equipment, get a lot of information from the people there and the people online. So yeah, at this point, let's say it was 2015, working with the electronic was really easy because of those two factors, availability and this type of movements and places. And yeah, at least here in Europe, you were able to order, I don't know, 1,000 pieces of the sensor that you wanted, like the one that is here, and the one that we use for our development. And you were able to get that in, 24 hours delivered to your place or your office. Okay, this situation was happening in Europe. As I told you at the beginning, I came from South America, and I know what is to be like far away from big suppliers, and it's not something that happens all over the world, but generally speaking, the availability some years ago was much bigger than it is now. And yet, this situation allowed the project to expand at the beginning because we were able at the time to work with physical prototypes, no, to buy components, solder everything, and iterate over prototypes, test the works, and of course the contact with fab labs and makers give me the knowledge and the practice to handle all that type of work. Okay, so it was a great moment to create something technological, in particular with electronics. Okay, but this wasn't meant to last, and in particular, what happened to us is that when we were preparing our first commercial proposal through a Kickstarter campaign, and I will tell you about this in a moment, the pandemic outbreak took place in 2020, and it was the beginning of a big change that was about to happen that I'm pretty sure that all of you have experimented on your daily lives, on your work. But not only that, I'm talking about that a change that happens in the electronical market, let's say worldwide market. And yeah, at that point we were projecting to create a development that was taking into account, of course, the ongoing market situation. No one was thinking that it will suddenly change. Okay, everyone was projecting electronic that way. Okay, if you needed a component, you can look in the manufacturing page, and it would tell you about the state of life cycle of that component, and you will know that we will produce for the next, I don't know, 10, 15 years, and you can plan ahead that you will be producing a particular piece of hardware with that component because you are guaranteed to know it. But yeah, the pandemic outbreak changed everything, and it led by several factors that I will now get into this now to what was called the semiconductor crisis. No, perhaps some manufacturers stopped production for a few months. Then there was logistical problems. Then some speculation on some actors that were starting to buy stock of electrical components and to retain it. The consequence is that from one day to the other, you were just not able to get what you needed. And yeah, excuse me. Yeah, that was the consequence of one of the consequences of the pandemic. The electronic market went crazy. Like one engineer friend of mine said at that time, when we were talking about getting a particular component, he said it's like far west out there. It's like, in order to get what you want, I don't know, there was also a parallel black market that of reselling pieces where you were able to get components that you needed at extremely higher cost than they were before, without real guarantees of what you were getting were quality products. Well, it was really crazy. I would like to tell you about this situation a little more, but let's move on to the next slide. So yeah, at that time, at the time of the pandemic, it happened to us that we were the accelerator startup and we were about to launch this campaign. Of course, it's a good idea for a company like us who has a backing community already active and robust to propose the first product to a crowdfunding campaign. Okay? The thing is that a crowdfunding campaign is something that you need to plan ahead. Okay? And we were, of course, planning that, and we had our release date on March 2020, just the days when the pandemic outbreak took place. So we were working towards this, and all the pandemic madness happened. At least here in Europe, there were lockdowns and all these changes in life. And yeah, at the time we need to review everything because we weren't sure if it was a good idea to launch something like this when you ask the community, the committed people to a project in that situation. So we had some crazy weeks in which we need to replan everything and a lot of meetings, and we like to be able to foresee that things were getting here with electronics availability. So we changed the our project. Yeah.
Hello, sir.
Thankfully, yes.
Sorry, sir, I'm interrupting you. Your voice is breakable. It's breaking. Hello.
Excuse me?
Hello, sir. Can you hear me?
Yeah, can you hear me?
Yeah, sir. So your voice is breaking.
Yeah. Now it's getting through correctly.
Yeah, yes.
It was
Now it's
probably because
audible
of
proper.
Yeah, okay. I will continue with this slide. I think that slide was slowing things down.
Okay, okay, sir.
So yeah, I was talking about the Kickstarter campaign, and I hope you get most of what I was saying. It was just a crazy situation with the pandemic, and we have to review everything, but luckily it went okay. So I will move on because I'm a little back in time. So I will move on. Let's just call that part of the presentation done, the historical part of this project. I hope you enjoyed, and let's jump in on the technical description. I will need to go a little quicker than I was planning, but yeah. So motion capture. You said before that we were using these IMU sensors, and in particular, excuse me, I will take a sip of water. In particular, we use this technology, which is widely used nowadays in several components, which is called MEMS, which stands for microelectromechanical systems. It's a really fascinating technology because it evolved from techniques used in the manufacturing of semiconductors. So techniques that were mastered by the industry in several years and evolved to the point in which a manufacturer can insert into a single chip actual microscopical moving parts. Okay, that's why it's called electromechanical, because in the same chip you have the microcontroller logic, excuse me, and these moving parts. For example, let's take a look at the structure in the lower left of the screen, which, as you can see, is big, a few micrometers, and it has these two structures, these comp structures that are entangled together, and one of both of them are held in place by actual spring-like structures. So they are allowed to go back and forward. And for example, if someone's moves the sensor in space, one of these structures will be getting closer to the other, and this change in position can be measured electronically. I don't know, for example, measuring capacity between them, capacitance. There might be other techniques, but let's think about something simple. And from that measurement, you can infer the force that is being applied, and for example, measure acceleration. These microelectromechanical systems are used in many other appliances, but yeah, what I'm telling you is the application in IMU sensors. So yeah, it's an amazing technology, and the fact that it uses these techniques makes that really inexpensive. Okay, these sensors give great precision, and they cost I don't know, a few less than $10 each. I don't know. I wouldn't make a. I don't want to talk about the cost, but yeah, they're really inexpensive for what they've done, and they are nowadays implemented like everywhere. Of course, each smartphone has one or a few of them, which is why a normal smartphone is able to identify when it's tilted or the position in space, the rotation in space that it is acquiring. The car industry uses that a lot. So yeah, there is a great availability of this sensor, and they are a great thing to do. And in part, they are pushing the development of our system and other inertial-based motion capture systems. So yeah, as I told you before, let's go to this, and then we'll say this. As I told you before, we have accelerometers in this array, okay? So we can measure linear acceleration. So one can think that that you can use that information to track the position of each one of the nodes, okay? So let's think of that again. We have a lot of sensors placed on the body. We want a way of getting data from this sensor and obtain a moving skeleton, okay? One can say, okay, I can know the starting position of this skeleton. I can ask the actor to start in a particular position. I might be able to integrate the linear acceleration, okay, double integrate it, and obtain change in position. So I can move each one of the joints, let's say, of the skeleton, and then obtain the moving skeleton. And this is, of course, the first approach when you start to think about how to deal with motion capture. But unfortunately, this is impossible to do. The double integration accumulates error in an amount that makes the estimate go way out of range really quickly. So this is something that you just cannot do, okay? And you need to assume there are proofs, like empirical proofs. When you try to apply this, you just get a completely mistaken result. So it's not a good approach. Instead, we can rely on some of the constraints we have, because we don't want to measure random movements. We know that those sensors, for example, will be deployed or applied to a human body. So we know that we will have this jointed structure, which is the 3D skeleton, that should be moved, okay? And we have a lot of constraints, which is a good thing, because it allows you to restrain our problem, okay? And basically, what we can find out is that we don't need to directly use translation, but we can start by rotating, as I told you in the beginning, each one of these bones. Excuse me, I need to have another sip of water. Yeah, I was telling that we need to, we can rotate each one of these bones, and since the length of each of the bones is constant, we will obtain a moving skeleton. Okay, the skeleton, you can think of it as a nested as a series of nested coordinate system or transformations. Okay, when you rotate one of these, the other rotates. And yeah, the length between them can be moved, but you can is normally constant. So when you want to do that, rotate this 3D skeleton, what you need is to obtain the absolute orientation of each one of the bones, of each one of the sensors in real time, okay? And as we said before, we have a gyroscope, so we have information about the rate of change in orientation, okay? The rotational velocity. We could try to integrate that directly, but as when we talk about linear acceleration, that will also lead to drift and errors. So we need to find out a smarter way of dealing with this. And what is normally done in this field is that you use what is called a sensor fusion algorithm. A sensor fusion algorithm is something that gets that data from several types of sensors to obtain a single results. And in this case, when you talk about sensor fusion in motion capture, you're talking about sensor fusion for IMUs. And what you want is to get the data from these three sensors, the gyroscope, the accelerometer, and the magnetometer, obtain a single absolute orientation. Okay, these fusion algorithms are normally implemented as Kalman filters or extended Kalman filters, and you can do other stuff like this a famous one, which is a complementary filter. But yeah, I won't get into the details of this, but instead I just want to describe briefly how the other sensors are used to get a single orientation. Okay, you will start with. I'm hurrying up because I'm getting enough time. You will start by a single position in which we'll start to integrate rotational velocity. Okay, so you will have this estimate rotating. But as I said before, there will be drift. It will quickly drift away from what is a correct estimate. So you can have these absolute references from the environment in order to correct that drift and make the result much more stable. Okay, much more stable. You will obtain something that is moving like the real sensor. So the first thing to have is the gravity vector. Okay, because we have accelerometers, which are great because they measure acceleration, and you can get to understand where the sensor is moving in the local frame, okay, in the frame, in the reference frame that we assume to be local, which is your room or the place where you are. But because of the way these sensors are built, they also measure gravity. Gravity is a force that is applied to all bodies, to us, to my computer here, and to my desk, whatever. And it can be measured by this sensor. And it's in fact a good thing and a bad thing because sometimes it gets in the way, but it's really useful for this sensor fusion algorithm because if you imagine a sensor in rest position, the only thing that you will measure is gravity. Okay, and gravity you are guaranteed to be pointing downwards. So with that measurement, you can obtain the vector that is pointing down. So you can start to build a reference frame that will help you correct the errors in the integration of the rotational velocities. Okay. Of course, when you start moving this won't be pointing strictly down, but the Kalman filter takes care of using the more reliable, giving more weight to the reliable measurements and not to the ones when it is moving. Yeah, another thing that you can do in order to obtain this absolute frame is to look for an horizontal component. Okay, you have the vertical one, and if you have an horizontal component, you can complete your reference frame. Okay, because the third axis just gets you can get it from a cross product of these two vectors. So the horizontal component, how do we get it with the sensors that we have? Of course, you all know that the Earth has a magnetic field, and the magnetic field is normally that people who had already seen or use a compass tend to think of it like something that is plain, parallel to ground, pointing north, but actually it's not, and it has a shape that is more or less represented by the diagram on the left, on the right, I think I say, where you can see that this field, this flow of this field is parallel to ground at the equator, but in other latitudes, it's either gets into the ground and goes out of the ground. I don't know, for example, here in Europe and in the place where I am, when I measure the magnetic field with the magnetometer, it has almost 60 degrees tilt from the horizontal. So it's more vertical than horizontal. Okay, but it nevertheless has an horizontal component. So since you already know the vertical component of the reference frame that you're building because of gravity, you can obtain the horizontal component of the magnetometer measurement. And yet this will allow you to end up building this reference frame. Will allow the implementation of the sensor fusion filter do this just like describing intuitively how things are working over there. Okay, so you build this and you are able to compensate for errors, and you will get absolute orientation for each one of the sensors in real time. And yeah, you can then put all that into the armature, and you will. It's not so simple, but basically the steps are there, and you will get this moving skeleton. Okay, so up until now, let me have a last sip of water. Excuse me. Up until now, we talk about the theory, okay? How you do this in theory. You need to do, okay, get the sensor, get the filter, whatever. I would like to show you briefly what the core data framework is doing to help you or help a user with this, okay? Basically, what you will need is to start with some hardware, okay? All this can't happen if you don't have the sensors to be placed in the body, and you don't have a way to connect all them and process all this data, okay? So what we provide from the beginning, the sensor on the component on the left, which is called Keyceptor, is like the main building block of the hardware of the system. There are components that implement an IMU, the sensor that we talk about several times during this presentation, and some peripherals that allow these nodes to be interconnected to one another. In particular, they can be daisy chain, so they have two connectors, one for input and one for output, and you can make a chain one after the other. These chains of Keyceptors can be connected to the piece on the right, which is called the hub. The hub is provided as the current version is provided as a hat for the Raspberry Pi that I'm sure many of you already know. The Raspberry hat is not part of our development. It's a microcomputer, a really powerful microcomputer in a very reduced space. So you can put the hat on the Raspberry Pi, which will act as a main processing unit. The hat can be connected to all the Keyceptors, which are fixed to different parts of the body. We also provide the textile solution, the fixing, the straps that you will use to connect all this to your body, because it's also an important part to be able to keep all the sensors fixed in place. At the beginning of the project, we let the user figure out whatever was the best solution for that. And with this, after the Kickstarter campaign, we also provide this textile solution, which is great. It really helps things get into place and really helps with the accuracy of the capture. Just one thing to point out is that, for example, the connectors that we are using here are RJ45 connectors, the one that are using regular Ethernet cables. And it was a decision that was taken together with the community after a conversation that lasted for years, because the connectors seems something that is just an accessory, but it's just a really, really important part, because you need, these are all moving parts, and you want to have a reliable connection during the capture. And we tested several types of connectors. They tend to ruin with time. This type of connector, instead, they support many plug cycles. Once they are plugged, they remain plugged with a robust connection. They are also quite easy to get replacement cables. Okay, as you know, as I said before, one of the keys of our mission is to provide a flexible, expandable, and system, and we want to rely on common parts as much as possible. So yeah, you with these connectors you can get spare cables in whatever local store you are, and yeah, this is one of the design decisions that we take, and which are really happy of, not only because of how it is going on, but this was also because the community contributed big time in this. Okay, so let's pass to the next one. This is the hardware. Again, I would like to tell you a lot more about this, but you can find out later if you need in our page much more information. And of course, we also provide a software layer to deal with all this hardware and all this information. Basically, the main processing happens in a software unit that is called Notocore. Notocore is like one of the most antique part of the system, but it was recently like rewritten from scratch, and we took the implementation, which was done in C++, and we wrapped that into a Python module. So now we have all the implemented units, the processing unit implemented in native language, which is compiled, which is really fast. But the interface to access and to use that like to glue together all the parts of the implementation is a Python API in the form of a Python module, something similar in a way of NumPy. I guess many of you know NumPy and know that it's really efficient because under the Python interface is running compiled code, which makes that really fast. And we also need our system to be really fast because we deal with real-time data and a lot of processing. So we need to go with something like that. So it's a quite handy software product, the Notable module. It's quite flexible. You can import that and do many things with motion capture. And one of the things that you can do is, for example, build the base suit that we provide. What we do when we provide a motion capture suit is to grab the Notocore module and other software pieces that I won't be telling you about right now, perhaps a little if I have some time, and use that to build the basic gear, which has the regular flow of capture, okay, which ends up in this visualization of the armature. But using the module, you can, I don't know, obtain subproducts of the processing because, for example, if you want to use motion capture for research purposes, you will often want to get much more data from the process, and our framework is something that allows you to do that, okay, to manage the capture pipeline as you want, okay? As you can see, not only we have this module, which is really flexible. I'm running out of time. Can I go like a couple of minutes more, or I have to end like at exactly in 3 minutes? Well, I'll just go on. Just let me know. I was telling that we have this module. What we normally do is to use that module in a server which exposes an HTTP interface which can be used from external clients to start the capture and manage the capture. And that allows us to implement several clients, okay? You can visualize and manage the capture from the outside, from a normal PC, because all this processing of the Notocore module is, of course, happening in the Raspberry Pi, which is connected to the sensors. For example, one of the main clients that we have is an add-on for the Blender software, as I told you before. And as you can see, it's node-based. So also here, you get the opportunity to manage the flow of capture as you want. You can, for example, at some point, get a subproduct of this processing and output everything as a CSV, or to plug that stream into a custom Python script, because as I told you, Blender has a scriptable interface, so you can put whatever you want into a Python script and process it live. Okay, what I want to transmit here is the flexibility of all this. And last but not least, we are currently provide what is called the remote console, which is an HTTP HTML interface which can be accessed by any browser. So you can manage the capture through this HTTP interface from any browser that is connected to the same network that the Raspberry Pi. We are working on this, but we will lead to a complete client in which we'll be able to visualize and manage the capture, and will allow you to, for example, manage the capture and see things from a smartphone. Okay, so this will make the system still more portable, because yeah, you will be able to use just a regular mobile, any type of mobile device to do all this work without the need of downloading and installing dedicated clients. Okay, so I think I'm running out of time. I won't be delaying this longer. So this is it for today. Thank you all of you for being there and attending this keynote. If you want further information, here you have the contacts. And yeah, this is it. Thank you.
Is there any question from participants?
Yeah, I didn't know if there were a space for a question, but of course.
Yeah, yes. Is there any question from participants?
Yeah, in online conferences, there tend to be no questions, because I don't know, it doesn't feel like we are in the same place. But yeah, if anyone has a question, please go ahead.
If there are any questions, please post them in the chat box. Participants, if there are any questions, please post them in the chat box.
Well,
Is there any question? Okay, I think.
yeah, it normally happens in online conferences. There
Yeah.
are not tend to be no questions.
Okay. Okay, I think there is no question. I think just, yeah. Okay. So on behalf of ASSMS IOIT College, I would like to express my gratitude to esteemed delegate of the ESCI 2023 conference. Thank you, our keynote speaker, Dr. Bruno sir, who blessed us with his presence and sharing with his findings and opinions today is about what is the motion capture, what types of motion captures technologies, what type of core data hardwares and softwares are used. So number of free softwares, electronics availabilities. That is a great information. Thank you, sir, for these useful informations to sharing with us today. So
Thank you for inviting me. It was a pleasure.
okay, sir. Welcome, sir. Thank you. Okay. Now participants can leave the session. Thank you.
Bye, everyone.
Okay, bye.